Hey guys, today we're going to learn what it means to shift equations vertically. Okay, so here we see that we have three lines and all three lines have the same slope. Here, here, and here. But they have different y-intercepts. Make sure to get into your notes the difference in the way or the number k that's added on to the blue line and the red line. In this case, k is positive, and in this case, k will be adding a negative because the line in this case was shifted up to the blue line and here shifted down. So we can see that k affects the number or the positioning of the line. Over here, looking at these two exponential equations, they don't appear to be the same shape, but they actually are. And you can see that right here, the shift is up 3. 1, 2, 3. Okay, make sure to get into your notes how g of x, this new function, appears to look like the function of x, but there's a minus 3 here. Let's find out what that does to the function. So graphing f of x equals x, we get a line that goes this way and then heads out this way. The graph of g of x equals x minus 3, this graph right up here, goes down 3 spaces at all points. And so you can see the y-intercept is now at -3, and the rest of the line also continues 3 positions lower. Okay, and now graphing y equals 2 to the x power, we have a point at 0, 1, a point at 1, 2, a point at 2, 4, and then a point at 3, 8, which is already off our graph. And you can see how this thing travels upward very quickly, and we'll sort of sketch in the fact that it stays very close to the x-axis and then turns and moves upwards. The graph of y equals 2x plus 3 has that plus 3 in there, and so every point along the way is above. Let's look at this point right here. This is plug in a 1, and so we have 2 to the first power plus 3, and that makes 5. So we have the point 1, 5. Okay, so we can see, whoops, it looks like I made a mistake here. I was supposed to add 3. 1, 1, 2, 3. So this actually turns right here and heads up and then comes down and goes right along the y equals 3 line. So we don't want this line here. And here again, you can see that every point is 3 above the point in the graph y equals 2 to the x power. That's a bit of a mess, but you can see how adding k, in this case a 3, increases the value of the second graph by 3. So now we're going to talk about the domain and range. And you'll remember in linear functions, the domain and range are all real numbers because they extend diagonally and all x's work. In this case, if you went back this way, we'd be traveling back the x-axis. And as you go this way, they all work this way. And the same is true of y values. As you head up the y-axis or down the y-axis, every value is covered. So the domain and range for linear functions are the real numbers. But something's going on over here when we look at the domain and range of the exponential function. This lower exponential function, which we had as y equals 2 to the x, has a domain of all x's, x's are all the real numbers because we can go as far back along the x-axis, and even though this curves up, all these x's work. but you'll notice that y must be greater than 0. There are no negative y's. Even if this is a negative number, we still have positive fractions. So what happens to the range in the second problem in y equals 2 to the x plus 3? Well, that new line, which I messed up last time, seems to hug right here, y equals 3. So the domain in the second problem remains x equal all the real numbers, but now y has to be greater than 3, not greater than 0. Okay, so here are two for you to practice, and I know you're familiar with linear functions, so these two should be pretty easy to graph. Over here, when we do the exponential function, create an xy table for each of these, and you should see that, actually you'll need two xy tables, one for each, and you should see that your y value especially should be off by 1. Take some time to graph both of these and see what the graphs look like. Okay, so the graph of the g of x equals negative 2x plus 3, we plug in when x is 0, we've got a 3, and this slope goes down 2 each time. And so it's like this. And then for h of x is negative 2x minus 5, we start down here at negative 5, and it also has that same slope. And we know that it's going like this. And so we can see the two parallel lines being formed, and we'd like you to compare how far apart they are, and you're going to be doing that vertically. In the exponential function, y equals 5 to the x, we plug in 0, 1, and 2, and we get 1, 5, and amazingly 25, which is way off the graph. I'm sorry, 225, because that's 5 squared. And so this graph stays right on the x-axis and then goes up incredibly fast. It seems like it's almost vertical, but it's not. So we had 0, 1, 1, 5, and 225. Trying these next group for 5 to the x minus 1, and we get 0, 4, and 24. And you can see that in each case, all of those points are going to be just below the purple graph. What's going on there? Well, they're so close together that it's hard to tell that they're one apart. Down here, it's a lot easier to tell. So we need you to talk a little bit about and identify the domain and range. Linear should be no problem. I'll leave that for you to do. Exponential, remember the x value or the domain in exponential functions is all the real numbers. But the range is going to depend on if you have anything over here. You write out the domain and range. In doing so, you should be able to ask, how does a vertical shift affect an equation? You'll have to say whether it affects the domain or range and what that effect is.